All right, folks, how's it going this morning? I think we'll go ahead and get started. Hopefully, you're able to hear and see me okay if you're hanging out on YouTube Live. If you can't at any point, hear or see me, make sure to let me know in the YouTube live chat. I will be kind of monitoring that. If you see me looking over to my right, that's what I'm doing. I'm taking a look at the chat to see if there's any questions. So if you have any, issues hearing, seeing anything during today's presentation, let me know. I'll try to fix that up as best I can. But all of those logistical things aside, what's up? My name is Kevin Winnery, and I'm a member of the Deno team. And today we're actually going to be talking about how to use a web development framework called Astro with Deno. So it's kind of an interesting case because Astro as a web framework was actually kind of originally designed for and remains today kind of optimized for Node.js as like a sort of local development environment. It is actually possible to use Astro pretty productively with Deno, but you do have to kind of tweak a few things in order to make that choice. So basically today what we're going to talk about is number one, like why you would even care or consider using Astro with Deno instead of Node or other local development or deployment options. So we'll talk about that just super briefly to sort of lay the foundation for why we care, why we're doing this at all. Then we'll take a look at kind of the simplest way to use Astro with Deno specifically and Deno Deploy, which is generating a static site, which is one of the modes in which you can use Astro. And we'll show how you do that, how you deploy that to Deno Deploy, which is actually like relatively straightforward. So we'll kind of talk through that, show how that works. And then after that, we'll get to what I think is a maybe more interesting usage scenario, which is using Astro in its server-side rendering mode so that we're actually dynamically generating content for our Astro site with every request. And this is kind of interesting in Deno and on Deno Deploy specifically because you actually have like then the full power of the Deno runtime, but in a way where your site is globally distributed across 30 plus data centers around the world, and you're actually building a globally distributed application server that's running Astro that's capable of serving your requests very quickly, and also taking advantage of some of like the built-in parts of the Deno runtime. So we'll take a look at how you do that, and after that, if we have questions, by the way, this is definitely a live code session. I'll be looking at chat the entire time. So very much not a structured presentation. If folks have questions, I'm happy to kind of deviate in any direction that would be helpful for the most folks. So if there's anything that I can do to answer your questions, I will happily do so. So with that, let's go ahead and dive in. So I'm going to start by sharing my screen here, and that will be the first test. Hopefully we can see that okay on YouTube Live. And we start off here like on the Astro website. So definitely a good place to start if you're going to talk about Astro. So I mentioned briefly that Astro is like a web development framework that has both like a static site and a server-side rendering mode. And what's kind of cool about it is you have the option to sort of take a hybrid approach where, some of your site's content could be statically generated, some of it could be server rendered, and you can kind of decide like on a per page basis, like which approach makes sense. Astro also has like a way of organizing your code and organizing your content that I think ends up being pretty interesting and is sort of built around this hybrid model of deciding like, all right, this page is going to render on the server, this one's going to render at build time. And from like a framework design level, there's actually, some amount of, affordance for this different kind of infrastructure. So the reason I also said I'd talk a little bit about like why you would even care about like running Astro on Deno. And the primary thing is that with Astro, you have like this architecture, this like developer experience that's very nice and kind of tailored towards building static sites or like content-centric apps. But with Deno, you have a full-fledged JavaScript runtime that's kind of designed to run as a globally distributed application server. So Deno actually gives the kind of the most powerful possible like edge runtime, or like a runtime that's running very close to your users that you can use from your Astro application. So it ends up being kind of interesting and possibly worth dialing a few knobs to use Deno in production or in development when you're building an Astro site, so you can take advantage of some of the Deno runtime features, like there's a integrated key value database in Deno, which we'll actually see as a part of the demo. There's lots of other parts of the runtime that might be useful or interesting when you're building a site in Astro. So the ability to use the Deno runtime, the ability to run on Deno Deploy, which is a pretty interesting hosting option, I think are two reasons to consider maybe running Astro on top of Deno. So let's jump in, and I think the first scenario we're going to look at is using Astro as a static site generator, and just kind of see what that process is like, and to deploy that project on Deno Deploy, which I think is kind of maybe the least exciting of the two options, but it's really simple, really easy to get going, and it'll allow us to kind of show you how Astro works if you haven't used Astro before either. So the first thing we're going to do is generate a new Astro project. And my recommendation is that even if you're using Astro with Deno and Deno Deploy, is you're definitely still going to need NPM specifically. Like a lot of the Astro documentation, shows how to run different management commands using NPM. A lot of the packages and integrations and adapters that Astro will sort of offer you as a developer are available through NPM. So a lot of your local workflow and dependency management just makes sense to use NPM for all of that stuff, just because Astro was kind of originally designed for Node as its sort of default local development environment. And for the most part, that's fine. What we're going to do instead to kind of take some of those parts and start running them in Deno instead of Node is actually we can start to modify the NPM scripts that are available in an Astro project. And instead of just running Node processes, we'll actually use that to kick off Deno runtime processes instead. So you can start to call built-in Deno functions and things like that. So let's go ahead and get started. So I've got this command copied over here. And if I run npm create Astro at latest, this is just sort of a bootstrap program that will help you, set up a new Astro site. And in this case, I'm going to mostly just accept the default. So a default folder, the sample files are fine. I think it's just sort of the default sort of purpley Astro, starter site. And I will install the dependencies because we are going to be running some commands through Node and NPM. So notably, Astro uses sort of behind the scenes both Vite and ES build, which are a couple of JavaScript build tools that exist in the NPM ecosystem. So as Astro is kind of processing some of the files in your project, that stuff is actually occasionally going to be using those NPM packages. So I do plan to write TypeScript. Even though this configuration is not, super necessary, I'll go ahead and add TypeScript support, and I'll, have the ability to use that both in my, Astro files and within other JavaScript or TypeScript files that I could see. Initialize a Git repository, and in a few minutes, we've got our new project ready to go. So if I pop in here and open this up in Visual Studio Code, you can see we have the kind of default Astro project already set up for us, notably a package.json with a couple of commands in the NPM scripts to run a local development server, build our site in a production mode, and also to preview our site after we run one of those production builds. And right now, the only dependency we need is Astro, which itself includes a lot of the tools that we need. The other thing that's at the top level, which is kind of important to note, is this Astro config file. And here is where you're going to sort of modify the behavior of the Astro build. And when we do a server-side rendering application instead of a static site, this file is actually going to have to do a little more work for us. So we'll come back there in a little bit. An Astro site has this public folder, and this is for any static assets that you want to serve to the client, mostly unchanged. And within the source directory, this is where some of the more interesting parts of an Astro application live. So there's this pages folder, which has a new file type that you might not be familiar with, which is a .astro file. And this is where I think a lot of the utility of Astro as a framework starts to come in, where you can, within this template, you can include code that is intended to be run on the client or on the client side. So we have a lot of sort of a JSX like syntax here, where we can create the HTML content for our pages, and also include layouts and other components from within our project. And then we can also include styles. So these CSS styles will be used on the client. And there's actually kind of a nice distinction here that isn't immediately visible in this file, but there's kind of two types of JavaScript code that can exist in one of these Astro pages or Astro components. And some of that code is inside this fenced block, like this front matter block in the Astro component. And this code is actually going to be run either on the server or at build time. So for a static site, this code is going to be executed while this page is rendered. So this is a good place to if during build time, you want to get data to include within your static site, this is where you'd write that kind of code. And then within the rest of the content, you can actually just include script tags. So this type of JavaScript is actually going to be shipped to the client, and can modify the DOM and do all those types of things. But by default, Astro doesn't actually ship any JavaScript to the client. So one of the nice parts about the framework there. And within these Astro files, you're going to be using components. So if you want to have sort of reusable chunks of code across your application, this is the way that you're going to one of the ways in which you're going to be able to do that. And then oftentimes you'll also want to have a layout component or other things that you can use to sort of use the same layout as we go. So this is kind of the basic Astro site. And if I go back out to my terminal, I can do npm start. And what this is going to do is start up a Vite dev server by default on localhost 3000. And this dev server has all the nice bits that you would expect, like when you make changes, there's hot module reloading. So if we did the code challenge as is prompted of us, we could go into the index file and say welcome to Astro with a bunch of exclamation points, and then without having to do too much work, we see those changes reflected for us. So the dev server, definitely a key part of the workflow if you're using Astro. But this site by itself, again, not super interesting as yet. But what I am going to show is just how you go through the process of creating a static site build, what that creates for you, and then how you can actually run that on Deno Deploy. So you have this static site available, worldwide in a reasonable amount of time. So the command we have for that is npm run build. And when we do that, that's going to use Vite and esbuild behind the scenes to actually generate a static site into a dist folder. So if we go back into VS Code, we can see that there's an index.html file that's been generated with style sheets that have like cache busting URLs, a lot of the stuff that you'd expect to see as a part of a static site build. So basically, everything that we want to ship to our our static file host is going to be in this dist folder. So that seems to be running pretty well. And if we wanted to, we could also go npm run preview, which is going to actually serve up the static content from that directory instead of using the dev server, which has a few more bells and whistles. So you can have a sense of like what it's going to look like in this mode as well. So our project at this point is basically all set. So we are ready with our static site. We can pretend we can do anything that Astro can do. We could add React components or any of the client-side frameworks that are supported in Astro. But once you have your static site ready to go, you can build it locally. Now it's reasonably easy to just go ahead and deploy it on Deno Deploy. So our first step though is going to be to create a Git repository, which will allow us to like host this code and then integrate with Deno Deploy. It is possible to deploy our static site from the command line as well. But for the most part, you're going to want to set up a GitHub integration. So I'm going to actually go through those steps so you can see what that looks like. So let's go to GitHub. And I'm going to create a new repository in my own, I'm going to be the owner of that. And we'll just call it, Astro SSG demo or something like that. So we can see, this repository we're going to create. It's just going to be a test. I'll keep it private for now since there's no good reason to share it with the world. And I'll create that repository and do a little bit of work here. When we generated the Astro project, it did create a Git repository for us. So make sure I have all the changes here. And then I'm going to add the remote for the repository. So just do that. And we will push it up to the main branch right away as well. So we've got our sort of default generated Astro static site. It's set up in our GitHub repository. Now it's a fairly simple matter to actually get this going on Deno Deploy. So if you sign up at deno.com for deploy, you'll sign up with a GitHub account right now. You'll end up with a dashboard that looks kind of like this one and hit new project. And in our case, what we want to do is deploy, this template application from a GitHub repository we already have. So I'm going to say select a repository. There's my username, and I'm going to select the Astro SSG demo, which I believe is the repo that we just set up. And Deno does some amount of detection for a lot of popular web frameworks. So it detects that Astro is the static site generator that we're using. It also detects that it's in, static site mode versus SSR mode, because there are, some slight differences in how you'd want to set up your builds in either of those modes. But one thing that might be kind of different from like other hosts that you might have used before is that, here, let me also make this just a little bit bigger so folks can see the browser, is that by default, actually, Deno projects that run on Deno Deploy don't require a build step. So if you're using like a Deno native framework like Fresh or something like that, that actually assumes that you're going to be deploying in like a server rendered mode, and Fresh actually doesn't deploy a build, like, need a build step. So you'll just be able to ship your code directly to, this network of servers, and, your changes are available within a few seconds. With Astro, because with a static site and actually with the SSR mode, there is a necessary build step. So we have to actually configure that build step to happen first and then automatically deploy to Deno Deploy afterwards. So we're going to say, add that build step. And it's going to prompt us to add this GitHub workflows file to our project, which is fine. I'm pretty happy to do that. And what's happening here is we're setting up our GitHub repository such that anytime there's a push to the main branch, we're actually going to deploy, or like going to build and deploy our static site and like push it out to Deno Deploy. So we'll clone our repository. We'll install Node because the Astro build process requires it. We'll run the build and install our dependencies. And then the final step is what's Deno specific. So we're going to use like the deploy CTL command, which is, and this is like a command line utility I could have used on my desktop too if I had wanted to. And we're going to deploy to this project that we just created, which has this loud starfish 52 kind of default name. And the entry point is just any kind of Deno file that can, serve to bootstrap our application. In this case, there's actually like a static file server that is a part of the standard library that we're just going to use to serve up the contents of our, of our generated static site on Astro. And the root of that generated static site is dist, as we saw a minute ago when we ran the build. So when I commit those changes, that's going to ultimately kick off like a GitHub Actions workflow that, once it's finished, is going to deploy our site. It's going to, run the Astro build. it's going to ultimately deploy the site. It looks like it's going to take its sweet time, but it looks like I have a runner set up now. All that is great. And for a simple site like ours, this build process actually shouldn't take too long. I imagine it'll be done within just a few seconds here. So we are uploading all the various bits to Deno Deploy, and I imagine that within moments we'll be all set. So if we go back out here, we can see already that the production deployment is live. So if we head out to loudstarfish.deno.dev, you can see our static site is basically all ready to go. Oh, we got away from Joe Nash, all the way from the Netherlands, perhaps. How's it going, sir? I'm glad you could hang out with us today. So our Astro site's all set. And without doing too much extra work, we were able to go from like a Deno, from a default like Astro app to having it running across 30 data centers worldwide in Deno Deploy. So while that is fun and a lot of use cases will be just fine as static sites, I think things get a little more interesting when you start to include like server-side rendering. That's when like the Deno and Deno Deploy actually start to do quite a bit more work for you in terms of like the features and functionality it adds to the application. So let's take a look at how to do that. I'll just show all these things down. I'll keep my deploy tab open here because we are going to want to go back to that eventually. And if you're interested in doing a server rendered application with Deno Deploy, I would recommend using this Deno Astro template. This is on the Denoland organization, and it contains a few tweaks that I think make this template maximally useful. There are just a few little things that need to change with like Astro's default like Deno support, and a couple like build tasks that I think are optimally ergonomic to set up in a certain way. So I would recommend using this template as a starting point if you're interested in doing an Astro Deno project. So there's a few ways we can do it. If you wanted to, you could actually just say, create a new repository based on this template, and it would already be in GitHub, and there would be probably fewer steps to actually deploying it on Deno Deploy, because we'd also want to use the GitHub integration. So we're probably going to do that, but I'll also point out that it's that you can use the Astro create command and use this template as well. So if you'd rather generate this from the command line, that's an option available to you as well. So that's part of the README here. But to save us a few steps, I'm going to create a new repository based on this template, and I'll call it Astro SSR demo. And I'll keep this one private as well, because nothing we're doing here will be terribly useful afterwards. And everything that we're going to show here is basically just in the template in any event. But so now I have this SSR demo that is kind of actually already set up to be deployed in Deno Deploy. So if I go back to my projects here and say new project and select a GitHub repository, I should be able to just go ahead and deploy this project right away without any additional configuration. So it's an SSR template. It detects that, this is, it still requires a build step. So I'm going to do that. And just like before, it's going to prompt me to add a deploy.yml, YML, is that what the thing people say? File to this project. But there are a few interesting differences aside from the static site generation that we saw a second ago. So instead, when we set this up to upload to Deno Deploy, we still want to specify our project identifier, but this time our entry point is going to be server entry.mjs, which is a Node.js convention for indicating that a JavaScript file is an ECMAScript module rather than a CommonJS module, which is sort of still the default. And as before, the root is the dist folder. But in this case, our build process is going to generate a file that we can actually use to launch a Deno application that will render our render content for the client on the server for most of our pages. So it is slightly different there. So in this case, again, I'm going to commit those changes. And that should all work just fine. And if I head out to this page here, in just a minute, that first deployment should be running. And it doesn't, again, for a relatively simple site like this one, it doesn't take too much time. So I imagine in just a few minutes, we'll be all set. But it's doing essentially the same thing. So it's checking out the project, it's installing Node, and it's running the npm install and the build process. But this time, the build process isn't just generating a static site. It's actually going to create both like a client and a server folder with some code that's intended to run on Deno Deploy on the server and some code that's intended to be shipped to the client. And as you can see in just a few seconds, the deploy is finished. And if we head out here and refresh the page, we can see like we already have this server rendered application as well. So it looks a lot like the project that we created earlier, like the static site. But I did include, just some simple CRUD operations that shows like how you would do some of the more dynamic, features that would actually necessitate doing an SSR application in the first place. So there's a form here that lets us essentially add links down to this little section down here. This is a sample app that I've been working on. Actually, if you've been showing up to the weekly live code sessions, this is the app that we've kind of been iteratively building together. And it's like a preschool for like Deno's little dinosaur characters. And basically what's happening here is this form is just a form. It's submitting a post request to this same URL. And then what's happening after the post request succeeds is actually a redirect back to this URL. So this page is server rendered every single time. The bit that's running client side is actually the delete. So if you were to delete one of these, one of these resources, then that actually is done by like executing a fetch request in the browser. So if we go over here, I guess it didn't see it because I didn't have the dev tools open, but that delete operation is happening client side. So this project is a little more advanced. So let's clone it, and we'll actually take a look at it locally to see how it works. But actually getting it up on Deno Deploy, as you can see, just took a couple minutes. So feel free to try it out yourself if you are so inclined. But let's head out to our SSR demo application, and we'll pull down this code locally. So here, let's head out to the terminal, and let's clone that repository. Show SSR demo. And let's take a look at what's in the box here. So the contents of the project are very similar to the what you would get with just the default Astro generation, but there are a couple minor differences, and some of the big ones start in package.json. So with an SSR application, we actually want to use the Deno runtime locally and at build time a lot of the time because we actually want to be able to take advantage of Deno namespace functions and like Deno platform capabilities, notably Deno KV, which is like a key value database that is built into the Deno runtime. It'll actually be in public beta very soon, so everybody can get a chance to check it out and deploy. But it's available in local development today. So anytime you install Deno, you also get the Deno KV database, and we'll flip that on in a second and kind of see how that works. But for that reason, we actually want to run our dev server using Deno instead of Node, because we're going to want to actually have access to those features. So we've replaced our dev and our start script with calls out to the Deno runtime, which you do have to have installed if you want to build the site locally. The build process, we actually still are just running this through Node. We could run it through Deno if we wanted to, but it would essentially do the same thing. Like it's not actually adding anything to the build process. But like if we had any like build time configuration or any code that needed to use the Deno runtime, we could kind of do basically the same thing. Like we could just say like Deno run Astro, npm astro.build. This syntax here, like this npm specifier, is essentially how you would run like npm commands or npx commands through the Deno runtime without actually even having to have Node installed. So that's sort of what's happening there. But in this case, it doesn't really matter. We can actually run the build process through Node, and it's not really a problem for us anyway. It also saves us, we have to have Node and npm installed in our CI environment. And if we don't need to install Deno in our CI environment, that also saves us, a few seconds on our builds. And, every little bit helps when it comes to build times in continuous integration. And for our local preview, we're going to run this through Deno as well. So this is going to run that entry.mjs file, which is like the generated artifact from the Astro build that runs our SSR like server essentially, so that we can run Astro on Deno and on Deno Deploy. Question from Fernando about like if the build process works for Deno with Astro on SvelteKit, it didn't work. That's a good question. Like npm support in Deno is something that we've been working on for a number of months. Not every package works perfectly. I suspect like with a little bit of massaging, SvelteKit could work. I haven't started to play around with it, but I'm about a month on the job here at Deno and kind of looking at frameworks and framework support as part of the work that I want to do. So let's keep talking, like hang out in the Deno Discord, and eventually I'm going to get around to looking at SvelteKit support. And Vite is a complex beast, and I think that's what's being used in SvelteKit behind the scenes, if I'm not mistaken. So there could be, some configuration monkey business happening there that we still have to look into. But here in the package.json, that's kind of the big change that you'll notice from the static site build that we looked at a minute ago. And also in our Astro config file, there's actually kind of a temporary change that's happening in here. So Astro actually, as a part of the core project, does provide what they call an adapter for server-side rendering for a lot of like popular hosting environments. So they have like an SSR adapter for like Cloudflare, for instance. So they actually also have one built in for Deno. And it works okay for the most part, but I actually had to submit a pull request in the last couple of weeks because I noticed that during the build process, it constrains the language features of the JavaScript that's going to run on the server to what would be ECMAScript 2020 standards. Kind of downstream when it calls ES build to actually process the JavaScript that gets generated and emitted to run on the server. But that's actually a little too restrictive for Deno. Like Deno actually supports like most modern ECMAScript features kind of out of the box, along with its like out of the box TypeScript support. So there's actually a lot of stuff that is valid code in the Deno runtime that was actually throwing errors in Astro because it was trying to build it with too many restrictions, essentially. So this patched version of the Deno Astro adapter uses much more like sort of permissive ES build settings and assumes that the runtime can use basically every modern JavaScript feature, which is true on the Deno runtime. So eventually you'd replace this line with this. Like I said, I did submit a pull request to fix this in the Astro project. But for like the next, I don't know, a week or so, however long it's going to take for that PR to get merged, I have like a patched version of it that I made available on NPM. So if you want to take a look at that, feel free to do so. But in the fullness of time, again, you would just replace this line with that one. And then the other bit that's happening here is we're going to change up the configuration for Astro to do server-side rendering. And what this is going to do is, when you build the site, it's going to create both the client-side code that's going to need to ship be available for static file hosting, but it's also going to generate a server-side runtime component that's going to handle routing and other business that needs to happen on the back end. While your source code actually looks about the same. Like you'll still use Astro components. Some of the code's going to be client-side, some of it's going to be server-side, that sort of thing. And then this adapter configuration, this is where you would use the Deno adapter if you're deploying on Deno. There's a Cloudflare adapter if you're going to run on Cloudflare. So if you're going to use one of the two available like edge hosting runtimes, this is where you would make that configuration. So that's a little bit of that. And then public folder again is just going to be static assets, and the source folder we'll get into here in a second. Let me actually fire up the server and just ensure that everything is looking good. So if we run npm start, that's going to fire up the local dev server, which again is powered by Vite. And if I head out to my browser here and refresh, I get kind of the default welcome to Deno screen with the 4 resource links there. So that all seems to be working as I would expect, which is great. So let's head back out to the code and see what's different about this application versus the static site. So in the pages folder, there's a little bit of extra stuff happening here. So in index.astro, my TypeScript configuration in VS Code is a little goofy. I don't know why it's not resolving those things, but obviously it runs just fine. But keeping the TypeScript configuration in VS Code happy, it turns out is a full-time job. That's been my experience so far. I'm kind of coming relatively new into TypeScript and VS Code and using those two things together. Kind of reminds me of enterprise Java in the 2000s, where you had to constantly mess with Eclipse and Java to get like your autocomplete working. It seems like the TypeScript world and VS Code is kind of in a similar place here in the year 2023. So anyway, that aside, there is going to be some code that inside these like fenced boundaries. And this code, instead of being run at build time, as it would be in the static site, this is actually going to be run on the server. So if there's a GET request to this index page, this code is going to be run on actually every single one of those requests. And on a GET request, all that's going to happen is I'm going to execute this code down here and get a list of resources from sort of my data access interface, which we'll take a look at in a minute. But if it was a post request, because if you remember, we had that form that just like submits to the same URL, I can use this Astro request method property to figure out like what the HTTP verb was. And if it was a post request, I'm going to get the data from the form and create like a new resource object, and then add that to my database, and then ultimately redirect like back to the home page with a GET request, so that we can avoid like duplicate form submissions. Because if we just like let the page render again and we were to refresh it, say, like it would submit that form like over and over again, which is not what we want. So we're going to use kind of the classic pattern of you get a page, you submit a post, that post request redirects to another GET request for a different set of content. And if you're going to do like sort of form handling in that way, it's a pretty common pattern that's been in use since time immemorial. And that's kind of how we would implement it here in Astro. And if we go down here and see what's going on, the client-side code looks very similar. So we have our layout, we have our title. One thing that we added is this form with that post method that we saw before. But this actually, there's nothing actually special about this. This is just HTML, and it'll work like an HTML form works. But what we did add is, instead of having all the list items hard coded in that list of resources, we get to use this JSX style syntax to loop through this set of resources that we fetched from our database. And for each of those resources, we'll dynamically generate a card object using the results that we get back from the database. The rest of this we won't go over too much. This is just CSS that's going to be sent to the client to make this page look slightly more attractive. But that's kind of the changes that we made there. And then if we go to the components directory, we still have this card component. But what's different about this is we actually do want to execute some client-side code in this case. So we are going to ship a bit of JavaScript to the browser to kind of power this component. And in terms of like how you can do client-side JavaScript in Astro, there's a number of different ways to approach it. Like you can integrate like one of your favorite libraries. So you could use React or Svelte or Vue or whatever whatever was most attractive to you. But you can also just write vanilla JavaScript too to kind of add some more interactive capabilities. And that's what I did here. So on the server, this like fenced block here essentially handles like when the pages are being generated. This helps like generate our HTML on the server. So like all of this is kind of happening on the server side, but on the client side, this script is actually being shipped and executed in the browser. So within the script, I'm just using a query selector to grab this delete span, which I feel a little dirty. This probably isn't like the most accessible or nice way to implement a thing that's actually a button, but in the interest of time, there it is. And when we click on that, we're going to do a couple of things. We want to prevent default, stop propagation, so that like when I click on this, I don't get the it doesn't follow the link or whatever that thing would happen to be. And then after we do that, we're going to get a data attribute for the title, which is the sort of key that we're going to need to add or delete one of these resources from our data store. URI encode it, and then we're going to make a fetch request with the delete HTTP verb to this /API/resources.json endpoint. And then we're going to assume if that completes successfully, we will remove the element from the DOM. So just pretty standard client-side JavaScript stuff. So this route, this actually uses another feature of Astro. So if you are doing like server-side rendering, you can create like non-HTML endpoints as well. So those are still going to be in this pages folder, but I put this particular resource like in an API subfolder, which is a reasonably common pattern within an Astro application under this file, like resources.json.typescript or TS. And conventionally, Astro, like a lot of frameworks these days, do like file system based routing. So this index page is at the root of pages, and that's the home page for our site. But for this like API route, which is /API/resources.json, this is configured to be at that route as well. So in here, what we're going to do is import this API route from the Astro package, and what you can do in one of these files is you can export functions that are named a certain way. So if I were to export a function named get, like that would execute with a get request. I could export a function named post, and that would execute for a post request. And it kind of lets me very easily set up like RESTful endpoints to handle backend logic that is more API-like that I might expect to execute via fetch from the client or something like that. So in this case, I'm going to use, again, like my data access layer, which we'll look at next because we do want to, make some tweaks there. And then we are going to, get the title component that was included as a URL parameter. And then we'll return a response with a 400, like if we can't find that particular resource. Otherwise, we will try to delete it and then respond with a 204 if we have successfully deleted it. So yeah, so this template actually, if you're just getting started with Astro, it does kind of show you like a couple of the pretty, basic bread and butter things that you would want to do with a server rendered Astro application. I have a little typo there. Switch this import to resources KV. I'm going to have to fix that in the template. But now let's actually, like basically everything that I just showed you, you don't actually need Deno to do any of that stuff, right? Like these are, JavaScript features that, could very easily be included in a Node application. But Deno has some new tricks that, your typical JavaScript runtime doesn't have. So one of those things, we'll start to see that right away, like within this data folder. So if we open up like resources .ts. There's a few things we can do here that aren't obviously possible within within just a JavaScript runtime. So the first thing is actually going to be like a top level await, which you'll start to see like when we look at the key value database. But there's lots of like JavaScript language features that aren't supported in a lot of other runtimes that do actually work in Deno. There's also like zero config TypeScript. So TypeScript code just runs on Deno without any additional configuration. But there's also nice built-in runtime features like the built-in key value database, which we're actually going to replace this resources file with here in a second. So this interface is kind of how we've been doing those CRUD operations that you've seen in the client. But by default, it's set up to actually just store the resources in this in-memory map, which obviously is not viable for production. But I did just kind of is useful to kind of show how this works across environments that either have KV enabled or do not. So this interface to add a resource, it just returns a promise that's going to fake being asynchronous so that it can add a value to this map. And kind of a similar thing happening for like the list and delete. We're just like adding and deleting and listing resources from that map. And then we're also like defaulting, or we're sort of bootstrapping our in-memory database here with some resources, which just are some object structures that contain all the information necessary for those 4 links on the homepage. So this is okay for demonstration purposes, but I think it's actually a little more interesting to take a look at what's happening in resources KV. So Deno KV, again, built-in key value database that works in Deno and Deno Deploy. And much like Redis, it kind of just provides a very, a robust like data store with, high throughput reads and the option to, do data access with strong or eventual consistency. Essentially just like giving you a lightweight persistence option that's built in without any extra work that you can use within your Deno applications. So this is kind of implementing the same interface, but instead of having an in-memory map, we're actually going to, use Deno KV to actually store this stuff in a database. The resource interface is the same, but how we implement that is going to be a little different. And this is maybe the first instance where we're going to use a slightly more advanced JavaScript runtime feature, which again is only supported in like more modern runtime environments like Deno Deploy. And I do see some asks for the dark mode. Noted that is definitely a preference. If you're watching this late at night, I can understand that this might be a little much. So hopefully you can bear with us here. But here we have the opening up this reference to a KV database, and we have the same interface exposed to us. We have like add resource, list resources, delete resources, and then also bootstrapping the database down here. But instead of adding them to like an in-memory map, we can use like the database to actually use Deno KV to store these in a durable way. So I won't go a ton into the APIs here that show how Deno KV works. That's definitely the topic of its own presentation or session right there. But Deno KV gives us the ability to get and set key data associated with a key. So, but one thing that's kind of built into Deno KV that doesn't exist. I'm sorry, just one request to up the font size there. So I'll try to blow it up a little bit and see if that works a little better. Hopefully that helps. But instead of just string keys, Deno KV, and which is actually built on top of in production a Foundation DB, which is a key value database that's open source project from Apple. You actually specify keys as like an array of strings or objects which will uniquely identify a object in your database. So it works a little bit like a RESTful URL. So like this key contains resources and the resource title, and you essentially store the resource like object structure, which is shaped like this one, at that key location. And then when you go to like pull values out of the database, you can actually get a list of keys by applying a prefix. So it's almost like, imagine like in the browser, you're doing like a get request to slash resources, and you would expect to get all of the resources back like at that, at that URL. A query to a KV database actually is sort of conceptually similar. So any key that exists in the database with this prefix of resources is going to come back as a result of this query. And then that query does sort of expose itself as an async iterator object. So you have to kind of iterate over each of those keys, add them to an array, and then this is kind of just how I've chosen to wrap this particular query. And then of course, each of those values from KV, I'd also like to sort of type those as a resource here in TypeScript, so that consumers know what the shape of that object is. And then we also have the delete function here. So if I want to change my demo application over to using KV instead of this in-memory database, there are two changes I have to make, which are documented in the README. So don't fret if you don't feel like you have to write all of this down. But basically, I'm just going to import this resources KV in the index page. And then I'm also going to go to my API route. And instead of resources, I'll make this resources KB as well. And then that should start reading this data from Deno KV instead of the in-memory store. So if I were to add a new URL that looks something like that, and add that to my KV store. This is actually going to be persistent using Deno KV. So it does persist across refreshes, but it also persists across launches of my application because it gets stored in the local KV database. So if I refresh it, it stays there as well. To note, like in local development, Deno KV, instead of using Foundation DB, actually uses a SQLite database. So I've set this up to just like pop all those files out into a local folder that's in my git ignore. So if you did want to inspect any of those files, you certainly can, but you can safely ignore that and kind of pretend that doesn't exist. So with that, that's actually going to be just about everything that's available in this template. So what we saw there is just kind of, all the pieces of this application, leveraging some like built-in Astro features to let us like build a CRUD application with server-side rendering. And all of this works just really well with the Deno runtime. So let's actually maybe finish this off by checking in these changes so that we can actually see this working in production too. So I imagine the two files I would expect to see changed are our API route and the index page, which is great. So we'll add those and say we're switching to Deno KV. Origin main. All right, so we'll push that up. And because our project is already set up with a GitHub action that will automatically deploy to Deno Deploy, this new deployment should be ready in like just a few seconds. So if we head out to our SSR demo, we can see the build is underway. But again, this, at least today, if you want to use Deno KV on deploy, you do need to have access to the private beta. So if you go to deno.com/KV, we are letting plenty of folks in, but like I said, we will be sort of opening the floodgates here and letting folks try out KV kind of by default in the next few weeks. So you'll have an opportunity to do that, but feel free to join the waitlist if you would like to get a look in the next couple of weeks before that happens. But yeah, it looks like our build has already concluded, which is exciting. And if we look over here, we can see we have a couple deployments to look at. This production deployment shows that we're switching to KV. And we can go out here and, in a second, we see like the, the values from our Deno KV showing up here. Yeah, so we can say just add a new value there. And then within this KV tab, there is some basic visualization. We're kind of obviously looking to make this slightly more robust, but you can do a little bit of searching of like the contents of your KV database. But this is, again, something we expect to kind of mature over time. But with that, I think that's actually going to be a pretty decent-ish place to wrap us up. But if folks in chat have any questions, I do have a few more minutes to answer some of those. So feel free to fire away if there's anything that I can answer for you, or you maybe want to take a closer look at within the next few minutes. I will embrace some awkward silence of the solo stream to give you the opportunity to ask said questions. But if I see none, that's also totally fine. If you go to discord.gg/Deno, you can sign up for the Deno Discord server. And myself, lots of folks from the Deno core team are hanging out there all the time. So feel free to say hello. There's also a help channel there. So if you have any questions or get stuck, feel free to ask us in the Discord. And lots of the community is super active there, which I'm super grateful for. And you'll likely get a response from somebody in the community pretty quickly. The core team is also in there answering questions from time to time. So feel free to, ask your questions there too. So one question here before we go though from Nick. So I used a local DB. Did deploy convert that? No, not actually. What's happening to like sort of take the default values and like stick them in the production database was actually this little bit of code that I wrote earlier on. So let me go out here. And every time that this module is loaded, like my data access module, I actually default, I sort of put in the same 4 resources every time. Just by like, this is just the behavior I wanted. Like I wanted these 4 links to always be there under these 4 keys. So no matter what, like just the way my code is written, there's always going to be 4 values in the database. Otherwise, I didn't do anything to actually sort of pre-populate the KV database on Deno Deploy with any actual data. Another question, does it support TypeScript? So yeah, that's kind of one of the useful bits about Deno generally is that there's 0 config TypeScript support. Like if you were to create a file called, foo.ts in your terminal and put valid TypeScript in it and run it with Deno run, that would just work. Like you don't need like a ts config file or anything like that. Deno natively understands TypeScript and can use it just fine. In the case of Astro, because there is that build step that happens, your code is still being like actually TypeScript compiled, but by like a Vite and ES build. Maybe not ES build. I think the TypeScript compilation happens in Vite, but yeah, Astro just kind of has TypeScript support built into its sort of tool chain. So it does work there as well. But Deno applications not using Astro natively understand TypeScript. Good questions. All right, so I don't see too many more flowing in. So I'm going to assume that we're maybe largely good. What's the URL to the Astro PR? We did have one more question sneak in. And here, I can see if I can pull it up. So here, that's the wrong browser. And I'm sure they're going to get to it. Like I submitted it like not very long ago. I think it was, 2 days ago. So definitely not time to bust out like the pitchforks pitchforks and torches yet, but this is the pull request that I submitted. It's 7687. You should be able to see it in the open PRs. And yeah, it just changes like the ES build target to ES next. So you can have like more advanced JavaScript features in your in the code that runs in SSR mode through their adapter. So I'm sure they'll pull this in before too long. All right. So again, I think that's probably going to wrap us up. Once again, I really appreciate everyone hanging out. I am going to be, in addition to like this recording being available for folks to reference, there should be a blog post ready. If not, like I'm guessing maybe tomorrow, maybe Friday, we'll kind of see how things are going. That's basically a written version of everything that we just went over. It kind of goes over like how to do static site generation, how to use this template for SSR, and kind of links out to all the various helpful resources. But I definitely do recommend giving Astro a try. Like I really like the developer experience of like the Astro files, allowing you to have a lot of the nice parts of like a framework like React, while still like not necessarily needing to bring that in until it's absolutely necessary. It's definitely a good option for Deno development. Kind of the canonical web framework for Deno is fresh, and that also does a lot of similar things. But I really like what like Astro's sort of developer experience and approach to doing some of the same things by sending zeros JavaScript to the client by default, and having like a really nice flow for doing server side rendering as well. So definitely worth checking out. Absolutely would encourage running Astro in production on Deno and Deno Deploy. If you have any feedback for us or things that you notice, would love to hear about it in the Discord. But until next time, it's been awesome, and we'll talk to you soon.